Electron spin quantum number. Electron spin quantum number using the symbol S represents the spinning motion of the electron in its own axis. There are two values of electron spin quantum number, positive half and negative half. Those values indicate two possible motions of an electron. Therefore, each orbital consists of two electrons with opposite spin. The electron can spin clockwise or anti-clockwise. Maximum number of electrons. For 2p subshell, there are three orbitals, 2px, 2py, and 2pz. The maximum number of electrons in an orbital are 2 electrons. If we look at this table, when n is equal to 1, L is equal to 0, M equal to 0, and the subshell is 1s. 1s subshell only has one orientation due to one value of m. One orbital can occupy with a maximum number of 2 electrons. Each electron in the same orbital must have opposite spin. Therefore, there are two values of S representing two different spinning. When L is equal to 1, M is equal to negative 1, 0, positive 1. So we have three different orientation. Three different orientation means you have three orbitals. So each orbital can hold a maximum number of 2 electrons. So you have 6 maximum number of electrons in 3 different orbitals. Likewise, when you have L is equal to 2, the values of M are negative 2, negative 1, 0, positive 1, and positive 2. So you have 5 orbitals. When you have 5 orbitals, 2 maximum number of electron in each orbital. So you have maximum number of electron of 10 in total in 5 different orbitals. Example 1. Write 4 quantum numbers for an electron in 4s and 3p. For 4s orbital, n is equal to 4, L is equal to 0 because it is s orbital, so L is equal to 0. When L is equal to 0, M is equal to 0. So, each electron can have S values of negative half and positive half. The set of quantum numbers must be in bracket N, L, M, and S. So, two possible ways in writing the set of quantum numbers are 4, 0, 0, positive half, or 4, 0, 0, negative half. You cannot write both because the question asks you to write for one electron only. For 3p orbital, n is equal to 3, L is equal to 1 because it is p orbital. The possible m values for L is equal to 1 is negative 1, 0, positive 1. Each electron have S values of negative half and positive half. So, set of 4 quantum numbers are 3, 1, negative 1, positive half, or 3, 1, negative 1, negative half, or 3, 1, 0, positive half, or 3, 1, 0, negative half, or 3, 1, positive 1, positive half, or 3, 1, positive 1, and negative half. You just refer all these numbers from the N, L value, and possible M values and making it as set of quantum number. Don't forget to write all because the question only asks you for N electron only. Example 2. What is the designation for the subshell with N equal to 5 and L equal to 1. So we know that L equal to 1 is p orbital. So the designation for the subshell is 5p. Indicate the values of m for each of these orbitals. When L is equal to 1, the m values are negative L, 0 to positive L. Therefore, the possible values of m are negative 1, 0, and positive 1. How many orbitals are in the subshell? When L is equal to 1, it is p subshell. So when L is equal to 1, your m values are negative 1, 0, positive 1. 3 m values represent 3 different orbitals. Give all sets of quantum numbers for electrons that occupy in these orbitals. So for 5p orbital, n is equal to 5, L is equal to 1. We've seen that the m values are negative 1, 0, positive 1, and each electron can have s values of negative half and positive half. The total number of electrons in orbitals are 6 electrons because one orbital can hold a maximum number of 2 electrons. Set of quantum numbers is in bracket n, L, m, and s. So these are the sets of quantum numbers for 5p orbital.